Hi, everyone. Welcome to our talk today. So today, our topic is to use WebAssembly to run AI inference. I am the founding member of Wasm Edge project. As you can see on the slides, that's our GitHub repo. It's a CNCF project. And Michael is the founder of this project, Wasm Edge. So I think we will start with two demos. We are going to run open source Gen AI models on your infra and or bundled with your own apps.
Thank you, Miley. Yeah, so I think the best way to get started, instead of explaining what is Wasm and why we use it for AI and all kind of stuff, I think it's probably easier if we just have a demo to see what we can do and what are the benefits. Why don't you use Python? Why don't you use Llama? Why don't you use any of the other large language model toolkit out there? So here is a GitHub repo that we prepared. It's called Talk. So let me actually exit from here and please excuse my messy desktop. It's here. So I'm going to run this demo twice. If you look at this UI, this is a lot of you may be familiar with this UI. It's a web UI, and it allows me to talk to my computer, and then it would generate some answers. So let me talk to my computer now. I hit record. I'm in Salt Lake City right now. Can you recommend some places to visit? So hopefully that you heard my question, right? I said, I'm in Salt Lake City right now. Can you recommend some places to visit? And I'm going to submit it. So basically, it sends this voice to a server. It's come back right back, okay? So, so here it says, I'm transcribed, I'm in Salt Lake City. Can you recommend some place to visit? And here's the answer in text and also in voice. So I'll play the voice and let you hear it.
Utah State Capitol, Natural History Museum of Utah, and Great Salt Lake. Also check out the Gateway Mall, Red Butte Garden, and Ensign Peak.
All right, so so this is it seems like a basic application, right? Just transcribe voice to text, use a large language model to answer the text, and then synthesize the text back to voice. Okay, so but what I want to focus on is that the whole setup requires very little resources. This whole setup runs on the lowest GPU machine you can possibly buy on Azure. So it's an NVIDIA T4. It runs 3 Gen AI models with their own runtime, with their own prompts, and with the entire application. It's just running on a single GPU machine, right? So this is the first demo. And I want to do the demo again. This time, perhaps go even more extreme. To have everything on my laptop. As you can see, I have a gazillion things running on my laptop. I have the Google Slides, I have everything. But I also have a large language model, and the Gen AI model that I talk about, right? So what I'm going to do is I'm going to ask a different question, So what should I ask? Should I ask? Okay. So what are the most important conferences of the Linux Foundation? My hope is that it's going to say KubeCon, but I don't know, So I'm going to submit it, and so basically submit locally. If you look at all the model now runs locally. I can even turn, because I'm presenting from Google Slides, so I can't really turn on my Wi-Fi, but I could. So here it says, what are the most important conferences in the Linux Foundation? Here, the Talk AI, I'll let it speak for itself.
The Linux Foundation hosts several key conferences. These include Linux Summit, Embedded Linux Conference, ELC, Open Source Summit, Cloud Native Con plus KubeCon.
Yay, did say KubeCon, right? So, yeah, that's so what I want to convey here is really that, I have a fairly low-end MacBook. The MacBook is like 3 years old. I bought it during the pandemic. And it's only have 16 gig of memory. And I'm running Llama 3.2 large language model, a Whisper V2 large model, and another GPT Soviet TTS model. So all of them, because we have a lightweight runtime, and we have a runtime that can handle multiple models. So we were able to run all of them on a single piece of hardware, or on very low-end cloud machine. So let me go back to the presentation and to go to the next two. So if you want to try this on your own machine, you can actually try this on your machine today. If you have a MacBook, or if you have a, say, Azure machine, running NVIDIA, that you can try today. Just go to that GitHub repository. It has all the instructions. You can do just what. It can even switch languages. When we demoed it from our booth, we have a contingent of Japanese people come by and they all ask questions in Japanese and they would answer in Japanese, which I have no idea what they talk about, but I'm told, it was pretty good. So, that's so it was great fun. If you have time, you should. You do that, and then this is just to repeat what I've said. There's three very popular GenAI models running on the same hardware, using a unified runtime that we call Wasm Edge, Llama Edge, which we're going to get into details in a minute. And the key takeaways here really is that there is a runtime that support multiple GenAI models. Not only just support large language model, but also support voice to text, text to voice, and what I haven't showed are text to image, stable diffusion type of models, and text to video, and things like that. It's extremely lightweight. So the entire application, excluding the large language models themselves, the entire application combined is 20 megabytes. Okay, so that's to give you an idea of how that compares, which we're also going to talk about in a minute. The PyTorch Docker image, at very minimum, is 3 gigabytes. It goes all the way up to 9 gigabytes. Okay, that's compressed Docker image. Okay, so we are talking about things that are 2 or 3 orders of magnitude smaller. That's and runs super fast and runs very lightweight and very fast. And another thing I want to highlight is the application that runs on the cloud NVIDIA machine that I showed in the first demo, and the local MacBook on the second demo are actually the exact same application. It's not the application that has been rewritten for the CUDA framework or the Metal framework on the Mac, being recompiled. I did nothing. I just copied the binary application using FTP, using SCP, directly from my development machine to the NVIDIA machine, and it runs off the box on the GPU right there, right? So, so 3 main takeaways is that, what I have demonstrated is support multiple GenAI models using a single runtime framework, very lightweight, and portability across GPU platforms. So I'm gonna turn over to Miley to do the second demo. Yeah.
Yes, thank you. So the second demo is a video translation tool powered by large language model and Wasm Edge. So I will show how a video that I have already translated from Chinese into English, but it's only subtitling. But you can also do dubbing in English or other languages. I'll play this first.
子期你好，好久不见。
好久不见。
可以说过去大概有3年的时间都没有更新视频哈。很多关心你的网友肯定都会在问，过去的3年的时间里头，子期都在忙些什么
Yeah. So that's a very short demo. So that's a very big influencer on YouTube. It's a Chinese influencer. She has been silent for 3 years, and that's. Recently, she started to post videos, so that's only in Chinese, but we uploaded this to this tool, video translation tool, and it get dubbed or captioned in English. So I will do a demo to the other way around, to upload an English video and get a Chinese translation. I'll open the videolengua.com. Let me open it. Yeah. So, I'm gonna do English to Chinese. And this is a video recording we did this August of Linus Torvalds. He did a keynote interview to talk about the scaling law of AI. So here I can choose whether to dub it or to caption it. So I'm gonna choose dub it in Chinese from English. So here I'm gonna enter my email address. After it's done, it would be it would send an email to me of the translated video. Yeah. While we are waiting for that, because it's also powered by large language models, so it can take a little bit. So we will come back to this, after we have finished the presentation. Slideshow. We will go on with our presentation.
So while we wait for that, I think one of the most interesting aspects of this is that, I'm sure you have heard of this term a lot. It's scaling law applied to inference, right? So for the longest time, we thought scaling law is on the training or pre-training side. When you train it by longer, when you train it with more data, the AI is going to be smarter. However, one of the strongest rationale, the use case of using open source AI is really because we have now scaling law at inference. This is a very sharp contrast with the demo that I just did. The demo I just did, I wouldn't say it's real-time audio, but it's semi-real-time, right? If I say something, I submit, and it comes back in like 2-3 seconds, right? That's 10 seconds tops, But for this video, even the video that Miley have shown is only 40 seconds. It takes a couple minutes to translate that. Why? Because in the whole process, we have multiple large language models to translate the same video, and they check against each other, and they give suggestions to each other which one is the best translation. So after a couple minutes, if you let the AI think longer, you would get a much better result. So that's where we have this system actually set up. When we had a KubeCon site event in China, we have this system set up to do real-time translation, and you would see the translation result is not that good. But if you give it sufficient time to think, if you give it a couple minutes to think about the 40 seconds video, it's gonna give you much better translation because it's gonna have multiple different large language models, and each of them gonna have different prompts. Some of the prompts would be to be context aware that this is the talk that's given in KubeCon China in Hong Kong. So it would know that the words in there are going to be pronounced in certain ways. So for instance, people talk about, people talk about Kubernetes or GitHub. Those are fairly uncommon words in the regular English-speaking world, right? So for the voice model and for the large language to pick up those words and understand what they are, oftentimes you would need special prompts. And in order to do all this, I think to have highly efficient runtime to run large language model on your own infrastructure is very important. It's not just a agentic system that I use all the same model that come from OpenAI. That they are all the same model and just prompted differently. That just would not give you, I think, the optimal result. What you want is the model that is fine-tuned and trained in slightly different ways, so that they would give different answers. That's when we see the same content, right? So and then you have those models to cross-check each other to say, then they would vote to say, which translation that they would want to use on each individual sentence, right? So this is the whole point. That's once we have done this demo, the takeaway point for this demo really is that, for agentic system, you really need multiple specialized models. You need applications to be tightly coupled with the models. Not just I write any application that's going to work for the OpenAI. It's that I'm going to write application that's specifically for this model, for the Llama 3.2, but not necessarily work for Llama 3.1. Because the prompt structure is different, right? The models are different. Or the model going to work for Qianwen 2.5, which is a Chinese trained model that understands that language much better, right? So, so there's lots of things that you can tweak yourself, if you have an open source based solution, a stack of solutions. And of course, it also requires very efficient use of GPU compute because, when you have all those models running, sometimes they all need GPU resources, sometimes they are all idle, right? So you need a highly efficient framework that can orchestrate, those workloads across GPUs. So let's go back and see if this translation is done. Where is it? Yeah, so it's done. You can play it.
Okay, I thought it would take longer. So that's Linus.
我的意思是，我非常清楚，今天可以使用 AI 来编写 JavaScript 和 Python 等语言。但我们还没有达到 AI。
Should we play the original?
Yeah, I think I think you get the idea, right? It's mixed English and Chinese. If you speak Chinese here, you'd be able to know. Because I speak Chinese, so I guarantee you, it's a good translation. So, but you can see that he makes the translation makes English word with Chinese words, and it handles it very well. So yeah.
Yeah. So go back to the presentation. Now, why Wasm? I guess for KubeCon attendees, Wasm might not sound that familiar, especially if you consider using it as a container. So it's not a so it's like comparatively young, but it's already being used in the browser for a long time. So it became the W3C standard, the fourth one, in 2015. And all the browsers supports WebAssembly. And in 2019, WASI got released. So that would allow Wasm to access system. WASI stands for WebAssembly System Interface. So that's when server-side Wasm is ready to go mainstream. And I was wrong. So W3C group was founded in 2015, and it became the fourth language for the web in 2019. In 2022, the CNCF survey have found that containers, that's the only key finding they have of that survey. That is, containers are the new normal and WebAssembly is the future. So this is a kind of recent news. So Wikipedia posted on their blog saying that it slashed a lot of milliseconds of its Wasm execution with Wasm Edge. So that's used on Wiki Functions. It's a serverless function platform integrated into Wikipedia, and it's one of the most popular websites worldwide. And so these posts have got over 120 views and 400 plus upvotes in just half a day. So why not Python?
All right. So thank you, Miley. So we had a good introduction. What Wasm? But then why do we use Wasm to drive GPU? So this is a question I always, when I talk to people who run large language model locally, I ask them, raise your hand. What stack do you use? And I would say 90% of them use Python. Okay. But because we automatically associate machine learning and all that stuff with Python. But Python is great for training models. It's actually terrible for inference, because it's extremely bloated. I dare not run Python without virtual environments or without, Docker, right? Because, in a few days, your computer will be completely unusable because, there will be version conflicts everywhere. So this is one of the big issues with Python. And Python is also, it's very bloated, very complex, and also that makes it very vulnerable to supply chain attacks and things like that. So to run it on production and public-facing inference frameworks and inference applications, I think it's in my opinion, it would be a mistake. And that is not just my opinion. That's so Greg Brockman here is OpenAI's CTO, and I quote him. That's modern machine learning engineering is making Python not to be a bottleneck, right? Because you spend so much time installing Python and try to figure out the conflicts and stuff like that. And if you look at what XAI did, they recently released their API. They have been promoting the idea of all their stuff is written in Rust. There's no Python that goes into their model serving and things like that. And also to echo the point I said earlier, just to prove it, is that if you do the PyTorch Docker image with CUDA in it, that's 8 gigabytes right there, almost 9 gigabytes, right? So that's compressed Docker image. That's when you explode it on your device, it's going to be a lot bigger, right? Just recall the entire application that I have just shown you, the 3-agent translation and question answer application is only 20 megabytes. Okay. So then, okay. No Python. Okay. Then what about other very popular tools like Ollama? That's I personally use Ollama. I like it a lot. That's I believe they're on stage at at KubeCon EU a couple months ago. But there are some issues when you try to use it not just on your laptop, but on say a cloud machine or edge device, right? So the biggest problem that we have encountered is that it only supports large language models. It's recently supported vision-based large language models, but it doesn't support things like Whisper or Stable Diffusion or things like that. But as you have seen, those are integral part of your entire application. So if that's the case, then you still need to introduce Python. You just use Ollama to run Llama. But the rest of the stuff, you still need to find solutions for that, right? The other thing is about the operational weight, because it's designed to be a desktop tool. So it sort of functions like Docker, so it has its own daemon that monitors the process, which requires sudo privilege, and it has its own repositories that you have to make sure you have connection to, and things like that. So while I like it a lot, I use it on my own computer, but I don't use it on the server for those reasons. So now we say Python is too heavy, Ollama may be too heavy. So why we just go straight to the most lightweight solutions? Why don't we just go to C++? Like we have seen, there's llama.cpp, there's whisper.cpp, there's torch.cpp, there's VRM, and there's a variety of different C++-based solutions where you can run your large language model, right? But as I mentioned earlier, that's why we did the first demo twice, is that portability is a really huge problem for C++, right? So especially when GPU was involved. Okay, so that's if you develop a C++ application on your Mac, you need to use the Mac GPU SDK, and it compile to that target and then run it. None of this stuff going to work on the NVIDIA stuff, and none of this stuff going to work on AMD. And with all those GPU and NPU, architecture that coming along, it become I think a huge problem for portability, right? Then of course, people are not really interested in working with C++ anymore, especially application developers. I think Rust and Go would be the languages they would much more prefer. So I think to provide a modern language framework that on top of those, but do not add much weight to that C++ framework would be the ideal case. That's why we created a Wasm Edge and the application on top of it called Llama Edge, right? So that's where you see parts of those demos. And before I hand over to Miley, I would also like to add, there's currently a couple 100,000 machines running Llama Edge to run large language model inference. So it's so if you ask me, it's production ready, right? So mostly our personal laptops or edge devices like Raspberry Pi type of devices or Orange Pi, or those Pi devices that has NPU on it, right? Robotic devices, and also edge cloud servers, like the servers and GPU servers you get from traditional CDN providers like Cloudflare or Fastly, places like those, right? So yeah, that's so Llama Edge is a Rust application that we built the large language model runtime on top of Wasm Edge. So, Miley.
Yeah. So Llama Edge is just like Michael mentioned, it's a set of tools, AI related to we build on top of Wasm Edge, and it's a dev platform. You can see it that way, and it allows you to build OpenAI compatible API servers. It would support multi-modal APIs and tool calls, and built-in search, and also RAG. So you can write in in different languages like Rust and JavaScript, and compile it into WebAssembly, and then it would be fully portable and lightweight. And so that's a GitHub repo for the Llama Edge project. And I think we have just already covered those. So it's lightweight and portable, and you can use any open source large language models on Hugging Face, and it's embeddable, and it's because it's already seamlessly integrated into the Kubernetes ecosystem. And it's officially supported by these different orchestration tools and Containerd and Fedora and Red Hat. So yeah, I guess that would bring us to the calling for contributor part. So as an open source project, we always need more contributors. So you can go check out our GitHub repo and check out these different tags like Good First Issue or Hacktoberfest, which allows you to win small gifts by finishing different tasks. And also LF mentorship. I think we are one of the project that provides the most mentors in the mentorship program with the Linux Foundation. So every year we would have 12 mentees, so 4 mentees each term, so 3 terms a year, and also Google Summer of Code. And yeah, and if you guys have successfully run what we have demoed or like have wrote an article about it, you can participate in this incentive program. And every month we would have a monthly community meeting at the first Tuesday of each month. And it's all public and everyone can sign up and join us. So we are gonna host a Wasm dev room in Brussels in Wasm, and right now the CFP has opened. And also, this GoSim is some new conference we just started from last year. So it's very similar to FOSDEM. It's hosted this year in Delft and Beijing this year. Last year it was in Shanghai, and it was a co-located event with KubeCon China. So, and also KCD 2025. I'm hosting KCD Beijing in March 15th, which would be the first Kubernetes community days of the world. So the CFP will be open soon. And also, we are one of the co-organizers for Rust China Conf. If you guys are interested in speaking, you can submit a talk. And that would be our QR code for our Discord community and YouTube. And also that's our GitHub and Twitter handles and LinkedIn names. So if you're interested, please reach out to us. And I guess that will be the end of it. Do you have anything to add, Michael?
No, I think we have a couple minutes. So, so if there's questions, that's we are happy to answer them. I know this talk didn't get into a lot of technical details, so we didn't really show you the Rust code that kind of, that perform all those. But they're not super complicated. Just go to our GitHub repositories. Those are, I think, like I said, compiling to like 20 megabytes, it can't be that difficult. So, so if there's any questions, please. No? Okay, then, so we're gonna stay here for the next couple minutes before the next speaker shows up. So, so if you have anything you want to talk to us privately, you can come up, and otherwise, thank you very so much for coming to our talk, and wish you a good day.